In this video, we're going to go through a few more circle theorems. So the next circle theorem we need to know is when you have a radius and a tangent. And the circle theorem for this is that the angle between the radius and the tangent is always 90 degrees. So let's take a look at this problem. So we've got a radius here, we've got a tangent. So I'm going to mark in the radius in green, and I'm going to mark in the tangent in blue here. So the angle between them is always 90 degrees. So notice I've got a radius here and I've got a tangent here. So also this is also going to be 90 degrees. So let's write down that circle theorem, that the angle between the radius and the tangents is 90 degrees. Okay, so we've written it down. So now what we can say is, okay, so we want to work out what angle OBA is, but this is OB and A. Right, so now we need to draw in another line. So I'm going to draw a line here. So we've got a little triangle here. Now notice it's going to be an isosceles triangle. So why is that? Because if I say that these are now both radii of a circle, so now we can say that OBA, so we want this small angle, so let's mark that in pink here, we want this angle, and we're going to call that the angle X. So what's that angle going to be? Well, there is a number of ways we can do this, and I think the easiest way to do this is to say, well, we have a four-sided shape here, and we know that all the angles in a quadrilateral add up to 360, so that will enable me to work out this angle OAB. So if I do 90 plus 90, and I'm going to add 36 here, then that's going to give me 6. I get 18 plus 3, which is 21, and I get 216, and then I'm going to minus that from 360. So we're going to do 360 here, minus 216, and we borrow 1 from the 6, so I get a 5, that can be a 10, so I get 10 minus 6 is 4, 5 minus 1 is 4, and then 3 minus 2 is 1, so I get 144. So this angle here is 144 degrees. So now what I have is essentially an isosceles triangle, because OB and OA are both radii of a circle. So if I get my highlighter now and highlight them so you can see them here, so this and this are both radii of a circle, and what we have is an isosceles triangle. So now we can say that, okay, all the angles in a triangle add up to 180, so it means that the angle OBA is exactly the same as angle OAB. So we can do 180 minus 144, so that will give me 10 minus 4, which is 6, 7 minus 4, which is 3. Okay, so both of those angles add up to 36, so we're going to do 36 divided by 2, which is 18 degrees. So we can now say that angle OBA equals to 18 degrees. So here's a question for you to try. You can pause the video and you can then look at my work solution. Welcome back. So in this question, we've been asked to work out angle OBT. So first of all, where is angle OBT? Well, it's going to be all of this angle here. So we want all of this angle. So how are we going to do this? So let's have a look. So what we could do is say, well, first of all, I've got a radius and I've got a tangent there. So now I can say that the angle between the radius and the tangent is always 90 degrees. So that's what we have here. So I've got OA and AT. So I know for sure that this angle is definitely 90. So then I can also work out what the angle is here. So I'm going to do 90 minus 58. And that's going to give me 8, and that's going to give me a 1 here. So I get 2, and that gives me 32. So I get 8, and minus that is 32. So that's fine. So now this angle is 32 degrees, and it means that this little angle here is also 32. That's angle OBA. Now we could also say, all right, well, what we have essentially is a triangle here. So I have a smaller triangle. So the triangle in question is ABT. Now I want to know what this angle is. Let's call it angle X. Well, ABT is a triangle, so we can say that 58 plus 41 is 9, and that's also a 9, so I get 99. So then I can do 180 minus 99, and then I can do, borrow one from that, 17, and I get the following. 10 minus 9 is 1, 17 minus 9 is 8, so I get 81. So I know that this value is 81 degrees, and I want to find the whole of angle OBT. So it's going to be angle OBT equals to 32 plus 81, and that's going to give me 3, and that's going to give me 11, so I get 113 degrees is the answer for that question. So 113 degrees, and we're done. And we need to also give reasons for our working out. So we're going to say, 1, that the angle between the radius and the tangent is 90. The radius and the tangent is 90. And we can also say that base angles of an isosceles triangle are equal. Base angles of an isosceles triangle are equal. And we're also going to say that angles in a triangle add up to 180. Angles in a triangle add up to 180 degrees. Let's go through. You can try this one if you like. Pause the video, and when you're done, you can look at my work solution. Okay, welcome back. We want to find this question. So we want to find the angle of size BCO. So B, C, and O. So again, we're going to draw down a straight line. So again, I've got a isosceles triangle, because OB and OC are a radii of a circle. So it implies we have an isosceles triangle here. Now, this is an important circle theorem here. Whenever we have an external point, the two tangents are always equal in length. So what we could say is that we've got another isosceles triangle, which is ABC. So we have two isosceles triangles that are formed. So, but we can also say, well, hang on a second, I've got a radius and a tangent here. Here's my radius, that's my tangent. So OC is the radius, and I've got a tangent line, which is AC. Now, we know that the angle between them is 90. So let's draw them in. That's 90 degrees. So again, we've got a quadrilateral, which is here. So now we want to work out what this angle at O is. Well, we can do that by saying, well, all the angles in a quadrilateral add up to 360. So we can do 90 plus 90 is 180 plus 40. Okay, and that's going to give me 0. That's going to give me 12 plus the 1 is 220. So I'm going to get 360 minus 220, and that's going to give me 0. That's going to give me 4. So I get 140. So this angle here is 140 degrees. Now, because it's an isosceles triangle, we can say that this angle is x and this angle is x. So we could say that, okay, we're going to do 180 minus 140 and then divide the answer by 2. So we do 40 degrees divided by 2, which is 20 degrees. So we get angle BCO is definitely 20 degrees. So angle BCO is 20 degrees. Okay, so our reasons are that 1, the angle between the radius and the tangent, the angle between the radius and the tangent is 90 degrees. 2, base angles of an isosceles triangle are equal. And lastly, that angles in a triangle add up to 180.